This lesson is on solving for side lengths of right triangles, and we're going to take what we know about trigonometric ratios and we're going to use them to actually find side lengths now. So I want to review real quickly that what trigonometric functions are when we take an acute angle measure as the input. So that's key. The acute angle measure is the input and the output is a ratio of the side lengths. Those are the two parts of a trigonometric function. And the three that we've talked about are sine, cosine, and tangent. So if we look at this, remember we talked about SOHCAHTOA. So sine is the opposite over the hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if we're looking in regards to angle B, the sine of B is going to be the opposite side, which is AC, over the hypotenuse, which in this case is always going to be AB. Remember, the hypotenuse always is the same. The opposite adjacent sides change within relation to which angle. So the cosine of B now is the adjacent angle. So this is adjacent and this is opposite. So the cosine of B is going to be BC over the hypotenuse, which is AB. And then the tangent is going to be, again, we're looking at angle B. That's the input. The opposite, which is AC, over the adjacent, which is BC. So those are good things. Make sure you understand what opposite, adjacent, hypotenuse are and what these ratios are. Once you know that, then this makes this a lot easier. So let's determine trigonometric ratios. So if we have a triangle, DFE, what are the inputs? Remember, that's the angle measure. So that's the angle. And the output is the ratio of side lengths. That's what it's talking about. So what are the inputs and the outputs? So in this case, we have the output is 4/5. Well, what's the input? So which angle? Now remember, if we're doing sine, it's either going to be D or F because E is the right angle and we're looking at the acute angles. So which one has a ratio of 4/5? Well, if I look at this, I say 20/25, and we reduce that, reduces to 4/5. So what side is, or which angle is opposite 20? Well, this is angle F. So the sine of F is equal to 4/5 because if we take the opposite over the hypotenuse, we get 20/25, which reduces to 4/5. So now let's take the cosine of F. What's the cosine of F? Well, the cosine is the adjacent angle. Here's our adjacent in this case. When we're looking with regards to angle F, this is adjacent, so the cosine is 15/25, and we always simplify. Those both can be divided by 5, so that is 3/5. So the cosine of F is 3/5. Now we're looking at the tangent of D. Now our input angle is different. Our input angle now is D we're looking at. So if we're looking at D, the opposite of D is now this side because it's opposite that angle, and the adjacent is the one that helps make up that angle. So the tangent is going to be the opposite, which is 15/20, which is the adjacent. And again, that reduces by, if we divide both by 5, we get 3/4. That's the input and the output, the angle and the side length ratio. So if we wanted to use this to estimate side lengths, so let's first look at what are the ratios, which one of these are correct. So sine of 20, so we're looking at, I'm going to put M, we're going to do green, and L we'll do blue, okay? So in this case, this is, our blue angles are the 70, and our green angles are the 20. So let's look in this case. So our green angles, if we're looking at M, because this is our 20-degree angle, the sine should be the opposite, which is ln, over the hypotenuse, which is 8. So that is correct. The cosine of 70, cosine, now we're looking at our blue angle, cosine of 70 should be the adjacent, which is ln, over the hypotenuse. Well, this is backwards, that's upside down, so that is incorrect. Tangent of 70, we're still looking at angle L here, tangent of 70 should be the opposite, which is mn, over the adjacent, which is ln. So is that correct? No, that's opposite, because if we're looking at angle 70, the opposite angle is mn. So that one is actually upside down as well. sine of 20 equals 8 over ln. Well, we did sine of 20 is ln over 8, so we know that can't be true. And now the cosine of 70 is adjacent, which is ln, over hypotenuse, which is 8. The other thing we could know is if cosine of 20, sine of 20, and cosine of 70, those are co-functions, so they should be equal to each other because they're the different. 20 plus 70 is 90, and so the sine of one is equal to the cosine of the other. So how does this help us find things? Well, once we know the correct ratios, we can actually solve for the side length. So if you'll notice right here, it says round to the nearest tenth. What is the length of ln? So we don't know this side length, but we do know that the sine of 20 is equal to ln over 8. So if I multiply both sides by 8, then we get 8 sine 20 equals ln. Well, what does that even mean? Well, if you pull up your calculator, right here you have a sine button. And you can just do 8, and then we take sine, and you'll notice that it has parentheses, and we want the sine of 20 degrees, and we click enter. And that gives us an approximation. So it's taking the sine of 20 degrees, which is usually a decimal form, and multiplying it by 8. So ln then is 2.7 if we round it to the nearest tenth. So let me see if I can move this over just a little bit. Okay, so we're going to use the information in the diagram to find the missing measurements. So we're given a 39-degree angle, we're given a hypotenuse of 30, and that's all we know. So what is the measure of angle G? Well, we know that if we take 90 minus 39, that's going to give us the measure of angle G, because these have to add up to equal 90 degrees in a right triangle. So 90 minus 39 is, measure of angle G should be 51 degrees. 51 degrees. Now we want to find HI and GH. So we've got to use what we know about trigonometric ratios. So let's set up a proportion. A trigonometric function. So let's use 39. So if we want to find HG, we know that the sine of 39 degrees is equal to HG over 30. And we want to get 30 by itself, so we're going to multiply both sides by 30. And so we're going to get 30 times the sine of 39 degrees is equal to HG. So then we come to our calculator. I'm going to clear this, and I'm going to say 30 times the sine of 39 degrees, and we round to the nearest tenth. It tells us that. So this should be 18 point, and we make that a 9 because 7 is greater than 5. So 18.9. We find that length. Now, we have lots of options to find. Oh, whoops, that's not HI. I found GH first, didn't I? 18.9. Okay, now we have lots of options to find HI. We could use the Pythagorean theorem. A squared plus B squared equals C squared. We could use the cosine of 39 degrees is equal to HI over 30. We could use the sine of G, or 51 degrees, equals HI over 30. We could even use the tangent of I or G, because those are opposite and adjacent. So you have lots of options. It really doesn't matter. In this case, let's use the cosine function just because we haven't used that yet. So if I want to find HI right here, and I'm using 39 degrees, that would be the adjacent side over the hypotenuse. So the cosine of 39 degrees is equal to HI over 30. And we're going to follow the same thing. Multiply both sides by 30. So 30 cosine of 39 is equal to HI. And then we just put it in our calculator. So we take 30 times the cosine of 39, and we get 23.3. Because when we round it, that's the way it is. So that's how we're going to use our cosine and sine. You're going to need your calculator. You can use an online calculator at Desmos, or if you have your scientific calculator, that's how you'll use it. So let's take a look at this problem. So this says we want to fix a window that's 23 feet above the ground. So 23 feet above the ground tells us this length right here is going to be 23. and we're given an angle of 75 degrees, and we want what is the shortest possible length of the ladder. So we want to find how long this ladder is. Well, what side of the triangle does the ladder represent? That is the hypotenuse, right? We're given a 75-degree angle, and this side is opposite over the hypotenuse. So let's set up a sine of 75 degrees is equal to the opposite side over the hypotenuse. And we know the opposite side is 23. And we don't know the hypotenuse, so I'm going to put x. I'm going to call x the hypotenuse. Well, now we're going to do the same thing, but notice the x is in the denominator, so I'm going to multiply both sides by x. Now I have x times the sine of 75. Well, I want to get x alone, so now I'm going to divide both sides by the sine of 75. So x equals 23 divided by the sine of 75 degrees. And then it's the same process, except we're going to be dividing now. So we're going to say 23 divided by sine of 75. And we get, now if your calculator does it like this, remember you can use this little arrow button right here and it will round it to the nearest tenth. So the shortest possible length of the ladder, it has to be at least 23.8 feet, and it says round to the nearest whole number. So the nearest whole number then would be 24 feet if we rounded that up to the nearest whole foot. So that's how long our hypotenuse has to be. So I'm going to draw this picture, and then I want to pause and see if you can do this on your own. So we've got a water tower. Water towers sometimes look like this. And it's 52 meters tall. So that's 52 meters tall. And the straight line distance from the top of the tower to the end of its shadow. So it's got this shadow. The straight line distance till the end of the shadow creates a 40-degree angle with the ground. So that's 40 degrees. And what is the approximate length of the tower's shadow rounded to the nearest whole number? So the shadow is this length right here. So you have an angle, you have a height, this side and this side. I guess we could put this over here. So see if you can set this up and solve it. Which trigonometric function do you need to use? All right, because I know an opposite and an adjacent side, I don't know the hypotenuse, I'm going to need to use the tangent. And I know the tangent of 40 is equal to 52 over 6. Or x, excuse me, 52 over x. You can also set this up as a proportion. If I put tangent of 40 over 1, then we can cross multiply, and we get 52 equals x times the tangent of 40, and then divide by the tangent of 40. The other way you could just do is cross multiply 52 divided by the tangent of 40, and then round to the nearest whole number is 62 meters. The other way you could have done this is you could have said, well, I know that this angle must be 50 degrees, and I could say the tangent of 50 is equal to x over 52. Because remember, we can use any function we want, and you would get the same answer. So double check that if you want on your calculator, but that's another way you could do it. Okay, so which equation can be used to solve for the length of xy? We want to find xy. This is a hypotenuse. So which trigonometric functions use a hypotenuse? Well, it's going to be sine or cosine, and we've got both of those here. So we have an angle of 41 degrees, and notice our answers are all in 41. So if we take 41 and we know 22, then we know the sine of 41 degrees is equal to the opposite over the hypotenuse, which is xy. Now if we want to get xy on its own, again we could do our cross multiply, so we have the sine of xy times the sine of 41 degrees is equal to 22, and divide both sides by the sine of 41 degrees. So xy is going to equal to 22 divided by sine of 41 degrees. So sometimes you're going to have to, so this is our correct answer. You need to set it up and see how it works. Okay, pause and see if you can do this problem. Okay, pause the video and see how you did. Now we're going to solve for measures of right triangles. So in this case, I want you to pause the video and see if you can answer these questions using finding an angle, the ratio, and the length. All right, pause the video and see how you did. Now we're going to do one calculating change in length. I've set up the problem. Basically, you need to find the distance at one part and subtract it from the distance when she moves forward. So see if you can work this out and then come back and check your work. Okay, pause the video and check your work. This is a several part problem, but this is how you can set that up.